This question appeared on a video which explained how to get data from multiple closed Excel files using ActiveX Data Objects. What this viewer wanted to do was basically the same thing, just using CSV files instead. Just to show you the basic setup for this video, I'm starting with a completely empty Excel workbook. All I've done so far is saved it as a macro-enabled file, and I've saved that in the same folder as another folder called My Files, and inside there are several CSV files, each of which contains a list of films made in a particular year. If I right-click on one of those files and choose to open with Notepad, you can see the basic data that we're going to extract. Let's get started in the Visual Basic Editor then by inserting a new module. And then the first thing we'll do is create a subroutine called Get Data from CSV Files. Before we start talking about the ActiveX Data Objects library, it's worthwhile mentioning that you can open up a CSV file as an Excel workbook. So the simplest possible way to get information out of one of those single files is to use the open method of the workbooks collection. I can say workbooks.open and then pass in the path to the file name that I want to open up. So I'm going to refer to this workbook.path first of all, and then concatenate to that a backslash to the My Files folder, and then I'll go for the movies 2011.csv file. That by itself is sufficient to open up that file as an Excel workbook. So if I run that subroutine, we should see a brand new Excel task appears, and it shows the list of values from the movies 2011 file. Now, if I wanted to work on each of these CSV files individually, the workbooks.open method is a perfectly sensible way to do it. But in this video, what I'd really like to do is get all of the data from each of those CSV files and build it into a single continuous list in another workbook. I'd like to do that without having to open up each of the CSV files in turn. So the technique we're going to use relies on the ActiveX Data Objects library to create a connection to each CSV file to extract the data without needing to open up the file itself. Let's close down the Movies 2011 CSV file first, and then we can head back to the Visual Basic Editor. And I'm just going to delete the line of code which opens up the CSV file as a workbook. And then I'm going to head to the Tools menu and set a reference to the Microsoft ActiveX Data Objects library. So Tools References, and then scroll down the list to find Microsoft ActiveX Data Objects. You should find several different versions installed. Just check the box next to the latest version you have available. In my case, that's the 6.1 library. Having done that, I can click OK. And then I can declare my first variable using that library, which is going to be called cn as an adodb.connection. Next, I can create a new instance of the connection class by saying setCN equals new adodb.connection. And then we can set the most important property of the connection object, its connection string. The connection string contains all sorts of information, such as what type of file or database we're connecting to, the location of that file or database, etc. And I'm not going to type in my connection string from scratch. I've just opened and closed some double quote characters there. What I'm then going to do is head over to the connectionstrings.com website, which lists out all the connection string types you could ever possibly need. So I've already navigated to the page for the Microsoft Text ODBC driver connection strings. And if I scroll down just a little bit further on the page, there's the basic connection string required to connect to a text file, or technically a folder containing text files. So I'm just going to copy that connection string to the clipboard, and then head back to the Visual Basic Editor, and then paste that connection string inside those double quotes. Just to tidy things up a little bit, I'm going to break this across multiple different lines using the continuation characters. So space underscore, and then I can start the driver part, or the driver property on one line, find the location of the semicolon character, which splits the driver property to the next property, dbq. I can then close the double quotes there and concatenate this with a space underscore continuation character, and then continue that connection string on the next line by opening some more double quotes. I'm then just going to close the double quotes again after the next semicolon, and then concatenate another continuation character, and then finish that off with the extensions property on the last line. Of course, we need to point to a different folder than the placeholder one that's used here. So this is currently pointing to c:\txt files folder. What I'd like to do is concatenate the location of this workbook's path and the My Files folder to that. So let's just change that bit in the double quotes there. Inside those / characters, I'm going to type in the name of my files folder. And then instead of C:, I'm going to break this part up into multiple different bits of text by closing some double quotes and then concatenating this workbook.path and then concatenating the / files / characters to the end of that. So that's the entire connection string created. At this point, it's worthwhile quickly checking that you can both open and close your connection. So I'm going to say cn.open and then a couple of blank lines and then cn.close. And if I use the F8 key just to step through this procedure, if I hit the cn.open line and that works with nothing apparently happening, then that's a good sign. If we didn't see any error messages, that's a good clue that we've connected to that folder of text files. Now that we've successfully connected to the folder containing the text files, we can start to select some data from each of the files. And to do that, we treat each of the text files in the folder as a table in a database. To extract the information and make it available to Excel, we're going to use a Recordset object. So let's head back to the Visual Basic Editor and declare a new variable called rs as adodb.recordset. What I can then do once I've opened up the connection is create a new instance of the Recordset class by saying set rs equals new adodb.recordset. There are a few properties of the Recordset I want to configure, so I'm going to say rs.activeConnection first of all to tell this Recordset to use the only available connection we have, which is called cn. And then I'm going to use the rs.source property to refer to the set of data that I want to select. Here it helps if you know something about writing SQL queries. We're going to write a select statement which treats the text file as a table. So let's go for the Movies 2011 CSV file first. Inside some double quotes, I'm going to write select. Then I'm going to use the asterisk character to represent all of the columns from, and then in some square brackets, the name of the file I want to get my data from. So that's going to be movies 2011.csv. Just as we did with our connection earlier on, it's worthwhile checking that you can both open and then subsequently close your record set. So I'm going to say rs.open and rs.close, leave a couple of blank lines to do the interesting stuff in a moment. And then if I use the F8 key once again to step through this procedure, if I hit the rs.open line and nothing goes wrong, that's a very good sign that we're successfully selecting data from that file. Next, we want to write out the contents of that record set into the worksheet in the workbook. So we're going to reference the sheet 1 object in this workbook. I'm going to use its code name to do that. So after we've opened up the record set, I can say sheet 1 dot, and then I'm going to refer to range A2. So I'm just going to leave a gap at the top of the worksheet, which we'll use to put the column headings in a little later on. Once I've referenced range A2, I'm going to use the copy from record set method, which does exactly what it says it does. It copies all of the data from the record set when you provide the name of the record set that contains the data you want to copy. So I can just specify rs, and then if I run the subroutine at this point, we'll find when I look back at the Excel worksheet, all of the data from the 2011 workbook, or CSV file I should say, has now been copied into sheet 1. Because I'm going to want to do this a few times, I'm just going to do a little bit of tidying up here. I'm going to make sure that this worksheet gets cleared out completely each time I run this subroutine, and then I'm going to make sure that we change the column widths to be the correct width at the end. So I'm going to go back to the Visual Basic Editor. Right at the beginning, after my list of variables, I'm going to say sheet1.cells.clear to get rid of absolutely everything. And then after I've finished closing the record set and closing the connection, I'm going to say sheet1.range a2.current region.entire column.autofit, just to make all the columns the correct width. So having done that, I can run the subroutine again, and I'll end up with exactly the same set of data, of course, but now all the columns are a better width to display all of the data. Let's move on and look at how to extend our select statement to include data from another CSV file in the same folder. We'll do this in a fairly simple way to begin with. Let's head back to the Visual Basic Editor. And I'm just going to copy the entire select statement, everything from the word select down to the end of the CSV file, including those square brackets. Having copied that, I'm then going to type in a space after the end of the existing file name, then type in the word union, and then paste in what I've just copied before I change the name of the file to Movies 2012. If I then run the subroutine again, we'll see that when I look back at the worksheet now, I've got data from both 2012 and 2011 in the same list. So that's the basic principle. We can use a union select to include multiple tables, and we can do that as many times as we like to build up the string. But I don't want to have to manually copy and paste here, of course. I might have a different number of files in that folder each time I run the subroutine. So the next stage is to get this select statement built up by looping through all of the files in that folder, and then we can simply pass that completed select statement to the record set source. Let's start by creating a couple of new variables to help. I'm going to head up to the top of the subroutine and add a new variable called movie file name as string. That one's going to hold each individual file name as we process the collection of files in the folder. And then we'll also have a variable called SQL string as string, and that will hold the completed SQL select statement. I'm going to try to capture the name of the first CSV file in the My Files folder using the dir function. So to make that work, I'm going to say movie file name equals, then type in dir and open up some round brackets. I can then pass in the path to the folder that contains the file I want to find. So I'm going to just copy and paste that, this workbook.path, ampersand my files up to the backslash. And then after the backslash, I want to find any CSV file in that folder. So I can use the asterisk as a wildcard character here, so any file name with a .csv extension. I can then close the double quotes and then close the round brackets. So that should return the name of the first CSV file in the My Files folder. I'm just going to use the F8 key to step through that. When I begin stepping through the procedure, the movie file name variable has an empty string. If I get to this point and I execute that line, we should be able to see in both the locals window or just by hovering the mouse cursor over the variable name, it has the name of the first CSV file in there. I'm just going to stop running the subroutine at that point, because what I'd like to do next is loop through the entire collection of files in there, trying to continue to find CSV files until we run out of files to find. So I can do that using a do until loop. I'm going to say do until movie file name equals an empty string, and then I can write the word loop to go back to the top. And inside there, the important thing to do to make sure we get onto the next movie file name is to say movie file name equals dir. This time I don't pass values to any of its parameters, and when you do that, it means that it just continues the search you started in this line. So we should be able to see now, if we use the F8 key to step through, we can see that the first movie file name is movies2011.csv, then the next one it finds movies 2012, and it continues going round this loop, updating the movie file name each time until we run out of movie files to find. So the last one in there was the movies 2016 file. Trying to find another one fails or returns an empty string, so then the loop continues, or the procedure continues with clearing the contents of the cells and then creating the new connection. So I'm just going to stop at that point, and then we can work out how we can start building up our select statement. So inside the do until loop, before I try to find the next movie file name, I'm going to say SQL string equals SQL string and the next bit of the statement. So I'm basically going to build on top of the SQL string each time, rather than replacing the contents, concatenate to itself the next part of the statement. The next part of the statement is going to be pretty much what we typed into our existing RS source line further down the code. So I'm just going to open and close some double quotes at that point, and then head down to the rs.source line, and I'm just going to copy the union select star from movies2012.csv. I'm then going to head back up to the loop, the do until loop, and then paste that bit of code inside the double quotes with a space in front of the word union there. Now, of course, I don't want to concatenate the name of the existing Movies 2012 CSV file. I want to replace this with whichever file name is currently held in this variable. I can't just directly reference the movie file name in this string. If I put the movie file name inside those square brackets, because that's contained in a set of double quotes, it will include that as a piece of literal text. So it will literally say union select star from movie file name. And I want to read the contents of the variable into the string. So just after the open square brackets, I'm going to close a set of double quotes and then concatenate the value of the movie file name variable. And then after the movie file name variable, concatenate the final closing square brackets to the end. At this point, I'm just going to, after the loop, write a debug.print statement to print out the entire contents of the SQL string once we reach the end of that loop. Then I'm going to set a breakpoint on the sheet1.cells.clear line. Then I can run the subroutine and it will stop at that point, but print out the full SQL select statement into the immediate window. And you should be able to see there that you can see the file names change each time we create a new select statement, all the way to Movies 2016. So at that point, I can just hit the reset button to stop running. Now, one small problem with the select statement we've constructed here is that we're not allowed to begin it with the word union. It has to begin with the word select, and then the word union goes in between each subsequent select statement that we include. So I want to strip off the word union and the first two spaces either side of that from the string. There are several different ways we can do this, but as a quick and simple example, before we debug.print the SQL string, I'm going to set SQL string to be equal to the results of a function called mid. The mid function lets you pick out a range of characters from inside a string. You start by saying which string contains all the characters you want to return, so that's SQL string, and then the position of the first character you want to return. So if I counted from left to right here, 1, 2, 3, 4, 5, 6, 7, 8. The 8th character is the first bit of text that I want to return. So if I type in the number 8 and then close the round brackets, then if I set a breakpoint on the debug.print line again and run that subroutine up to that point, when I hit the F8 key, we'll see this time the entire select statement starts with the word select rather than with the word union. So I'll just stop running the subroutine at that point and clear the breakpoint by clicking on the red dot there. And there's our SQL select statement constructed. We can now take the results of our SQL string variable and use that to set the source property of our Recordset object. So let's head down to the line of code which sets the source for the record set and replace that entire string with a reference to what we've just built up and constructed in our SQL string variable. Having done that, a quick check on the worksheet. At the moment we've got nothing in that worksheet. So if we run the subroutine again now, we ought to end up with a full list of all of the data from each CSV file from 2011 through to 2016. Next, let's look at how we can get the column headings from the record set and write those into the top row of the worksheet. To do that in the Visual Basic editor, let's declare a new variable which we can use to count through the fields collection of the record set. So I'm going to declare a symbol variable called I as integer. Then, once I've opened up the record set, I can use a for next loop to count through the collection. So I can say for I equals 0 to rs.fields.count -1. The fields collection is indexed from 0 in ActiveX Data Objects, unlike many other Excel VBA collections which start counting from 1. So we have to go from 0 to 1 less than the count of fields in the collection. I can then say next I, and inside that loop I can write out the name of the field object into the appropriate cell in the worksheet. So I can say sheet1.cells, and then in some round brackets, the row number will be 1, that's the first row of the worksheet, and the column number will be I plus 1. I can then set the value of that cell to be equal to rs.fields, refer to the index number that we're counting through using the I variable, and then refer to the name property of that field. Having done that, if I run the subroutine again, we'll end up this time with the field names written into the top row of the worksheet. Now you might have noticed a few unusual characters have appeared in front of the first column name that we've written into our worksheet. Those characters indicate the byte order mark, and this is something that's included in the text file to tell another program what type of encoding has been used for the text contained in the file. If you're interested in reading more about that, there's a good article on Wikipedia, as there usually is, about byte order mark. And you can see in this table a little further down the page that we're using the UTF-8 encoding system for our text file. You can see those same characters appear in that table. All I really care about in this example is how to get rid of those, and we can use a similar technique to the way we got rid of our existing or additional union keyword at the beginning of our SQL string. We can use the mid function to get rid of those first three characters. So once we've written out all of the column names into the worksheet, I can then add a bit of code that will say sheet1.cells and then refer to row1 column 1 dot value and make that equal to the mid function, and then use the exact same value sheet1.cells 1,1 and then start from the fourth character. So extract or omit the first three characters from that string. So having done that, if I run the subroutine again, this time we'll see we get the column names without those additional characters at the beginning. Now that we have all of the basics working, we can start playing around with the select statement to affect the way the results are returned. Let's start with something simple that will change the order of the results so the longest film appears at the top of the list. To do that, we can head back to the Visual Basic editor and scroll up to find the section where we're manipulating our SQL string, and let's just make use of our debug.print statement. Let's get rid of the debug.print statement itself and say SQL string equals SQL string, and then concatenate to that an order by clause. So I've got a space in front of the word order by there, and then after the word by I can reference any of the column names that I know exist in our select statement. So I can refer to the runtime column. I've got to wrap that in some square brackets because it has a space in its name. By default, the order by clause works in ascending order, which you can optionally state ASC, but I want this in descending order, so I'll say DESC and then close the double quotes. Having done that, I can run the subroutine again, and this time when the results are returned, I'll see the longest film is sitting at the top of that list. We can also choose which rows get returned by applying criteria using a where clause. Let's say, for example, we only want to see films that received at least one Oscar nomination. To do that, we have to add a where clause to each separate select statement. So in the union select all from movie file name, just after the closing square brackets there, we could add a where clause which refers to the Oscar nominations column. Wished I'd picked a shorter column name to type in because I'm having trouble doing this. There we go. Finally, Oscar nominations greater than 0. Having done that, I can run the subroutine again, and this time we return fewer rows, only those whose Oscar nominations value is greater than 0. So there we go, there's the basics of extracting data from CSV files using ActiveX Data Objects. Hopefully that's enough to answer the original question. Do feel free to keep on asking and I'll do my best to keep up with the answers. Thanks for watching, see you next time.